process. And the data we have reveals that projects with energy models achieve 8% or better energy performance. So we are supposed to, in the process of performative design, we create analysis models. We have the opportunity to create these models at different phases of design. Could be schematic design phase, or later definite design phase, and so on. But in the course that we have in our university that I'm going to present, we prefer working in the early phase of design. It can be called like conceptual design phase or schematic design phase. This is the area where we can make the most impact to the process of sustainability. We have, in the decision taken at this level, have consequences for the following phases. In order to create a performance building, in order to create a building model to be used for performance analysis, we need certain type of information. Those information sources are, we need to have building geometry at least. It is supposed to be three-dimensional. And we have to decide, of course we have to know that, what building type we are working with. Because comfort data or standards change from one building type to another. We have to know, I'm talking about conceptual design phase. We are creating a model for conceptual design phase, and we want to use this model for performance analysis. And these are basic needs that we need to have to create such analysis. So we have to know the opening ratio in our building, what percentage of our surfaces contains windows. We have to know local climate data for the building's region. It would be nice to know the site and surrounding topography, existing built environments. They are all taken into consideration during the calculation of building performance. So this is a course taught at postgraduate level. We have at Sunum University. In this course, students are expected to design a project using performance analysis. They are asked to decide on a building type when we begin. We have a limited time during this course. We don't have much time. It's not like a studio project. And they are supposed to decide on their construction site, building site. We only give them the size of the site they are supposed to select. Also, different from other projects, they are only required to design the shell, outer shell of the building. We don't have much time to spend on inside of the building. They are required to have general knowledge about the distribution of functions within this building. So they are expected to submit weekly analysis regarding energy, sun-shadow relationship, solar, daylight, and wind. At the end, they submit a final project. That final project should fulfill all the energy requirements defined in the earlier stages of the course. In this course, we use a BIM software. We prefer using Revit. There are other ones to be used as equally good as Revit. And the process starts like this. They design a model. They generate a model. They use the model to create simulations. These simulations provide us graphical visualizations. Those could be charts or some Excel kind of spreadsheets. And we analyze different possibilities for different design solutions. If our first initial goal, objective is satisfied, our task is complete. Otherwise, we have to go back again introduce a different new design alternatives and continue in this way. We start like this. What is the objective of this building? What are we supposed to achieve with this building? This achievement is metrics. We are asking them what kind of metrics we are going to use. They would say this building is supposed to achieve for a library building this much energy use, and certain amount of this energy should come from renewable resources, mainly solar energy. They say like 30%. They do all this modeling work and create performance data. At the end, what happens is that if the result is not satisfactory, they go back and optimize their design. There are different areas that we emphasize on this course. Energy is the most important for known reasons. This course has hands-on exercises done on software level. There are also theoretical aspects of those courses. They explain, when we talk about energy, they explain the way the buildings lose energy or gain energy, the cooling needs of buildings, the heating needs of buildings, and those kind of information. So this is one of the practice. They start with a simple shape, and then they specify the building type and how many of these surfaces, what percentage surfaces has glazing in this building, and then they create results like this. In these results, by using this information, they identify where the areas the building lose energy or gain energy, what strategies they need to apply in order to achieve a balanced energy result. This goes like this. They introduce different alternatives, schematic mainly. In these alternatives, they create different analysis. And then if they satisfy the requirements, they finish their task for that specific part of the course, for example, energy. After energy analysis, or going together with energy analysis, we have some share of studies. They explore the relationship of our proposed building with the surrounding buildings. Here we checked what kind of shading our building creates, shadows it offers, and then we decide whether this design is appropriate for the task, or we have to change it. For example, in this one over here, we ask them to specify the best location for a parking area, park play area for nursery school. They checked the yearly shadow analysis. They did sun shadow analysis and made a proposal about their position, the position of the park area. We had these studies based on different times of the year: summer solstice, winter solstice, equinox times, when we have the shortest day, longest day, and days and nights are equal. One other area that we work in this course was sun radiation analysis. We used our beam models again. Using beam models, we created different types of analysis. One is based on color coding. Light colors represent the most lighting, the areas that receive most light. In addition to that, we have been able to create spreadsheet kind of information. Each cell represented different sampling points from that surface. So we had different types of practices. For example, in this one in the bottom over here, we had four different types of alternatives. We tried 4 different types of alternatives. In these alternatives, we checked how our proposed building affect an existing building's access to sun. And we changed our design not to give harm to the rest of the surrounding buildings. In this one, we explored different roof types, sizes, and check which one of them produce the most amount of sun radiation energy. In this one, a very basic example. In this example, we experimented with different profiles of sun shading devices just to see which one is going to cool the most the wall that it is placed on. So we have done all different types of alternatives in this course and came up with different solutions. Students have been aware of the fact that buildings includes important other consideration than aesthetics alone. Okay. So thank you very much. It was supposed to be short, so I presented very fast. And these are information about my blogs. There are different types of tutorials, my course materials placed in there, but mostly in Turkish, I'm afraid. Okay? Thank you.